Right, welcome back to the next tutorial, wonderful people. We are still in N4 mathematics, and then we are going to try and solve trigonometry in engineering N4 mathematics. So I'm going to get rid of everything that is in here, and when I am done, I am going to work on this question. So we are in question 3. In question 3, they say that we should simplify. 3.1, they say we should simplify sine squared x 1 over 1 plus cos x plus 1 over 1 minus cos x. This is exactly what we have, and we need to simplify that. 5 mark is provided for this. Okay, that is fine. How do we simplify something like this? Okay, I'm going to leave that sine squared, and I'm going to work with what is inside of the brackets. A fraction plus and a fraction. I will take out an LCD, and the LCD will be 1 plus cos x and 1 minus cos x. For somebody who studied pure mathematics, grade 10, 11, and 12, you should be able to recognize this. So you would have your LCD as 1 plus cos x, 1 minus cos x. And then you would say this into this goes once, this times 1, it's 1 minus cos x. Addition sign, this into this goes once, this times this, it's 1 plus cos x. And this is what you will have. Very good. You can see that this is positive, this is negative. They will cancel, and you will have your sine squared x. You will have your 1 plus 1, that is 2, divided by 1 plus cos x, 1 minus cos x. And then from here, we are going to simplify the denominator so that we can see what we will have. So you will have your sine squared x to divide. 1 times 1 is 1. You will have minus cos x plus cos x. They will cancel. You will have minus cos squared. I hope you follow exactly what we are saying there. And I know sine squared x plus cos squared x equals 1. So meaning take this to the other side. Sine squared x equals 1 minus cos squared x. So where I see this, I'm going to write exactly that. So I will say sine squared x2 divided by sine squared x. Numerator, denominator goes once, and your answer becomes 2. A very, very easy problem to work on. Very, very easy. It just required that we have a little bit of understanding from grade 10, because this is a grade 10 problem, trigonometry, but it appears in your N4. But truly speaking, it is a grade 10 problem. Okay, be that as it may, let's go to 3.2. So in 3.2, we have the following. They say we should simplify. And what is it that they want us to simplify? They want us to simplify the cosec of 360 minus x cot of minus x the cos of 90 minus x be divided by sec 360 plus x the sine of 180 minus x and the tan of 90 minus x. Formula is provided for this, and let's see how we can solve this. Now I'm going to take you through a Cartesian plane so that I can remind you of some of the fundamentals that you need to understand when it comes to the cosecs and secs and everything. The Cartesian plane would be 0, 90, 180, 270, 360. They are all positive. 360 plus 360 minus 270 minus 180 plus 180 minus 90 plus and 90 minus. And on the second quadrant, second, first, third and fourth, only sine and cosec are positive, only tan and cot are positive, only cos and sec are positive. Just an overview of the Cartesian plane. And then when we are done with that, let's look into this one. So cosec would be on the second quadrant, and 360 minus, it's in the fourth quadrant. Cosec, it's negative in this quadrant, so this would be negative cosec x. I will assume that you understand this from grade 10, 11 and 12. Multiply cot. I know that cot, you have cot of a negative angle, that will be negative cot x, okay? Because I know that the sine of a negative angle equals, the cos of a negative angle equals the cos of a positive angle. And then 90 minus would be the first quadrant, and all the trigonometric ratios are positive, but the name changes from cos to sine. Divide. Sec, it's on the fourth quadrant. 360 plus, it's on the first quadrant, they are all positive, so that will be sec x. 180 minus, it's in the second quadrant, sine is positive in that quadrant, sine x. 90 minus would be the first quadrant, but now 10 must change the name from 90 minus. 10 changes to cot. Okay, now when we are here, what can we do? Remember, there's only multiplication. This into this goes once, this into this goes once, but the negative remains. So what is it that you have in here? Negative times negative, that's a positive. So you will in essence have cosec x divided by sec x. And I know that cosec, it's 1 over sine. So this is 1 over sine x, that is divided by sec, and I know that sec, it's 1 over cos. And I have my 1 over sine x, change division to multiplication, you will take the reciprocal, and you have cos x over sine x, which is cot x. This will give you cot, because cos over sine, that will give you cot. Is it cot? Yes, it should provide you with cot. And then when you are done with that, we are more than happy with that. Now let's check whether what we have done was correct. Okay, so we said this must cancel with that, this must cancel with this. We are left with this and this, and we know that cosec is 1 over sine and sec is 1 over cos, and the reciprocal is cos over sine. So this is what we have. I think we are correct in what we have done. This is negative, this is negative. Cos, the name changes from cos to sine and tan. Let's try to look at something here. Wait a bit. Let's do this. Wait a bit. Let's not say tan changes to cot. Let's rewrite this as sine of 90 minus x all over the cos of 90 minus x. Just to be very, very safe. Let's try to be very safe with this. Please, let's try to be safe. We are still correct to say this into this would go. And let's say we are left with negative cosec x times negative cot x all over, let's say, sec x multiplied. Now let's say sine of 90 minus. The name changes from sine to cos. Let's say cos x, because this is the first quadrant, they are all positive. Let's also say the name changes from cos to sine. Please, let's do it in this way. Let's try and do it in this way. And then be that as it may, let's say negative times negative is a positive. Let's say cosec, it's 1 over sine. So let's say 1 over sine x for this times. Let's say cot, it's cos x over sine x. Divided, let's say sec, it's 1 over cos times cos x over sine x. And let's say this into this goes once, and let's say, okay, we're having 1 times cos is cos x, sine times sine is sine squared x. Okay, this is being divided by 1 over sine. Okay, that is fine. Let's change division to multiplication. Cos x sine squared x. This would be sine x all over 1. And if I cancel sine and another sine here, I'll be left with cos x over sine x. And this still gives me cot x. So I was correct to say that tan of 90 minus would be cot x. But is this correct? That should be the question. Is this correct? That we should have an answer of cot. Yes, I think this is highly and highly correct. We are highly and highly correct. Yes, this is correct. What we have done here, it's highly and highly correct. Yes, I was just trying to check whether even if when we do this in terms of sine of 90 minus and cos 90 minus, whether it would provide the same answer, and fortunately it does. So this is highly correct. Right, now let's go to 3.3. And in 3.3, they say to us, solve for theta if 2 cos squared 2 theta, 2 cos squared 2 theta plus cos 2 theta minus 1 equals to 0, and they say that theta should be an element between minus 180 and 180. Theta should be an element between minus 180 and 180, where both minus 180 and 180 are inclusive. So how do we go about solving for theta now? Now, remember this can also be rewritten as 2 cos 2 theta, and that is squared, plus cos 2 theta minus 1 equals to 0. And I can say let cos 2 theta be equals to k. I can have 2k squared plus k minus 1 equals to 0. And I can try and play around that. I can honestly try and play around this. I can factorize this. What you will do here, you will take this 2 and multiply that negative 1. You will find something like, take that 2, you will find k squared plus k minus 2 equals to 0. So instead of factorizing this, we are factorizing that. So I'll have my k and my k. The factors of 2 that can give you 1, it's 2 and 1. The bigger number takes the sign of the middle term, and u must be negative. Okay? So that 2 which you took and multiplied the value of c with, you divide every number here with that 2. K plus 2 divided by 2 is 1. K minus, because 2 cannot go into 1, you take that 2 and you multiply k. So you'll have 2k, and then you write your minus 1 equals to 0. And then you solve when you are here. K plus 1 equals 0, or 2k minus 1 equals to 0. K equals minus 1, or k equals 1/2. But I know what k is cos 2 theta. So cos 2 theta equals minus 1, cos 2 theta equals 1/2. And I'm looking for the value of theta. That is exactly what I'm looking for. So I'm going to try and erase this piece, and I'm just going to take this all the way up here. Right, and what I'm going to do, let me just copy that. Cos 2 theta equals minus 1, or cos 2 theta equals 1/2. Now remember, I'm looking for the value of theta here, so I can divide by cos, and my 2 theta would be cos, arc cos of minus 1, and because this is negative, we will deal with that. Or I can come here and say 2 theta equals arc cos of 1/2. And what I will find, I'm looking for a reference angle there. So what I will do is to say arc cos of negative 1. And this would provide me with 180 degrees. Okay? And this is not a reference angle. It's never and ever a reference angle. So I would cancel this. I would rather go and find this one. Arc cos of 0.5. And I will find 60 and 60. Yes, this is 60. This is my reference angle theta. So I can work with this because the reference angle should be an angle less than 90. So instead of looking at this, I'm going to look at this. So this becomes my angle. I'm looking for 2 quadrants where cos is positive because 1/2 is a positive number. So I know that it's positive in the first quadrant. So 2 theta would be 60 degrees plus k 360k is an element of an integer because the period of course it's 360. This is how the grade 12s and the grade 11s would solve this, and they would divide everything by 2, theta being equals to 30 degrees plus k 180. K is an element of an integer. Okay, and then secondly, not only in the first quadrant is cos positive, it's also positive in the fourth quadrant. So in the fourth quadrant, your 2 theta would be, remember that is 360 minus 60 degrees plus k. 360, k is an element of an integer, and you would divide everything by 2. You'd find your theta as 360 minus 60, that is 300. Half of 300 is 150 degrees plus k 180, element of an integer. Now, remember they said theta should be between minus 180 and 180. So taking both into account the values of positive and negative, something worthy of noting. So what we would do there as a solution for this is very, very important. Right, the solution, because we have two values, 150 and 30, what we will say is that the solution for this, the quadrant solution, the solutions in the quadrants, remember we are taking both positive and negative. So you would have, remember, if we start with a negative, I know that negative 180 is smaller than negative 30. So I'm writing this in ascending order, and I would take my 30 and my 150. These would be the quadrant solutions. Where did I get this 180? Minus 150. Sorry. Minus 150 because it's smaller than minus 30. And then I have 30 and 150. Writing this in ascending order. So these are the quadrant solution based on this restriction that theta should be an element between minus 180 and 180. So you are taking both positive and negative angles in those quadrants, and then when you have done that, you know that you are just fine. So this is something worthy of noting, and they should give you whatsoever mark that needs to be there. Right. Right. They say to us in the last problem that we should prove. They say we should prove. Let me just do this. In 3.4, prove that the cosine of 60 minus 45. This is a grade 11 problem. This is equals to root 2 plus root 6 divided by 4. So divided by 4. We should prove that the left is equals to the right. Now, how do I do this? How do I do this? Now, I know how to work with this. I can try and work with this using the double angle formula, whatever that is. I know that the cos of A minus B, this is cos A, cos B plus sine A, sine B. I know this, and I'm going to apply that exactly on that. So meaning the cos of 60 minus 45, that's cos 60, cos 45 plus sine 60, sine 45. Okay, and we will try and check what is the cosine of 60. The cosine of 60 should be 1/2 because they are special angles. And what should be the cosine of 45? And the cosine of 45, let me just do this. Very good. And that should be root 2 divided by 2. Plus, what is the sine of 60? Root 3 over 2. What should be the sine of 45? And that should be root 2 divided by 2. Okay, when we are here, I can multiply root 2, 4, root 6, 4. Taking out an LCD, root 2 plus root 6 over 4. And therefore, the left-hand side equals the right-hand side. This should be, this is the simplest problem that you could ever find in N4 mathematics. Or maybe that's because this is a March question paper. I am not sure. So this is all what we have for now in question 3, and I will see you in the next tutorial.